In today's data science demo, we're going to build this agentic AI. Notice here, we're giving it a prompt and it's going to return some data science. We're going to build this in 10 simple Python lines of code running in a Google Colab notebook accelerated with an NVIDIA T4 GPU. The LLM we're going to use is hosted on build.nvidia.com. Let's get started. There's 5 steps to running our data science agent. First, we have to go get a Google Colab notebook. Then in that notebook, we're going to add a GPU, in our case, a T4, NVIDIA T4 GPU. Then we have to go to build.nvidia.com and get a free API key so that we can interact with our LLM. And then step 4, we put that key in the Colab notebook. And then finally, step 5, we run our data science agent code. All right, step 1, Google Colab notebook, pretty simple. Just search Google Colab here. First result is usually going to be the right one. Click new notebook on this blue button here, and that should be it. There we have it. Step 1, easy peasy. All right, for step 2, we need to add our GPU. Really easy to do in Google Colab. Very similar to Kaggle notebooks if you're used to those. One way you can go over to this runtime and say change runtime type here. I always find it easier to work over here with this little triangle here. You click this triangle, same thing, change runtime type. I'm going to use a T4. If I had maybe 10 gigabytes or more data, this should still work fine, but as I go up in data or algorithm sophistication, I might switch over to an A100 or L4, but for our demonstration today, the T4 is more than enough. All right, so we'll hit connect. It'll connect automatically if you just start writing code. And to make sure we make the most of our GPU, I'm going to run this magic command, load ext or load ext qdf.pandas. This %load underscore ext is an IPython. It's going to load the extension, and then qdf.pandas is Q is CUDA or CUDA-X, and DF is data frames, meaning Spark, pandas, polars. So this qdf.pandas is saying accelerate the pandas code for us without having to change our pandas code. So if you have pandas code today and you put this magic command above your pre-existing pandas code, it's going to automatically accelerate it on the GPU. One way we can verify is if we say, import pandas as PD, and then we just do a display on that alias there. We can see fast equals QDF, and then slow equals pandas. And then to verify we have our GPU hot and ready, we can see this GPU memory dashboard widget. You can see the T4 has 15, I think it's spec'd for 16 gigabytes of memory, and then our underlying CPU or host system has 13 gigabytes of memory. So again, when we have this load ext qdf.pandas, and then we add the import after that magic command, when we run pandas code, it's going to run it in the GPU. If for some reason, that function or whatever is not parallelizable or it's not implemented yet, it's going to run that function on the on the CPU for us, unbeknownst to us, just gracefully fall back to the CPU, run, and then sync back to the GPU using something called unified virtual memory. All right. So that is step number 2. Step number 1, we have our Colab. Step number 2, we have our GPU working for us in the Colab notebook. All right, for step number 3, we need to get our free NVIDIA API key to interact with an LLM that's hosted on NVIDIA's data centers. So the first thing we do is we go to build.nvidia.com. If you don't have an account, again, it's free. When you click login in the top right here, if you don't have an account, I'll zoom in here. Click this NVIDIA developer program. I'll open it up in a new tab. Again, this is all free. You just click join, top right, put in your email. You'll get sent an email with a confirmation code. You punch that code back in. Pretty standard process. Then you'll have an account. Go back to the normal size here. I'll zoom in a little bit. All right. Then you click login and you sign in. I'll go ahead and sign in privately here. All right, I've gone ahead and signed in, and this green button, Get API Key, this is what you'll click. And you are limited. You can't, just do 1 million requests per second against any of these open models, but it's enough to build a prototype or proof of concept here. This says 40 requests per minute, so that's more than enough for our demo. All right, I'm going to click this generate key. All right, and now this key here, I've got mine blurred, but this key is how you authorize yourself to call LLMs hosted on NVIDIA's resources. And these are all the popular open models that are hosted on very large NVIDIA GPU models for you to use. Click this copy key. Nope. Click copy key. All right, it copied, or you can click this button here, copy key, and then I'll hit close. And then over in the manage API keys, you can delete it. I'm going to go ahead and delete mine, since just in case for whatever reason, I'll delete that key, delete API key. Again, I can generate another key. This time I'll give it, let's see, 10 lines of code demo. And I'll set it to the shortest period for security. And again, I'll hit generate key, but I'm going to fast forward this part. Copy key. All right, there we have it. I've created my key. That is the end of step 3. All right, we're on step 4. Step 1 was creating our Google Colab notebook. Step 2, we spun up our NVIDIA T4 GPU in that Colab notebook. Step 3, we went and got our NVIDIA API key so that we could use an LLM. And now step 4, we have to take that key, that NVIDIA API key, and integrate it into our Colab notebook. And it's actually really pretty simple. All right, so I've copied that key. I'm going to go back to my notebook, and over, let me zoom in here so it's easier to see. There's this little key icon. Actually, let me close this. GPU is still running and we haven't used it yet. So this little key icon here is where we put environment variables or secrets or passwords. As I hover over it, it says secrets, but anything that we want to use here that we don't want to just share, we put that here. Now, I'm going to go ahead and delete this so you can see what it looks like from scratch. This is, unless you've used this before, yours will be empty and look like this. And I'll say add new secret, and I'm going to give it a name, and I'm going to say NVIDIA API key. It can be whatever you want, but I'm going to put that. Now I'm going to paste the key that I copied from build.com. I'm going to hide this thing. Whoops. Hide. All right. Now to use that in my code, I don't want to just paste it in the code, right? I want it to be obscured, hidden. Google Colab has this nice feature down here where I can just copy and paste this code to use the secrets up here. Now, this import statement, I'm going to go ahead and add that up here, put it with my other imports. And I'll go ahead and click Shift Enter to run it. You can also hit this little play button. And we don't need this anymore. This was just to look at it. I'm going to hit DD on my keyboard. Actually, that did not work. I'm going to go ahead and delete it with this trash can icon. All right. So I've imported this from Google Colab, or from google.colab import user data. Shift Enter to run it. Now that I have user data imported, I can use it. Now, there is no key over here named secret key, so it'll throw an error when I use that. Right? Secret name does not exist, but let me add a sample one here. I'll say sample key, and then I'll say ABC123. All right. Now, if I take that sample key here and put it over here, the output should be ABC123. Grant access to the secrets. All right, and there we have it, ABC123. So as you can see, if I put this NVIDIA API key and I put this here and run it, it's going to output our secret NVIDIA API key. So that is how, and I'll go ahead and delete this sample one. So that is how we integrate our NVIDIA API key into the Google Colab notebook, and that concludes step 4. All right, so finally, step 5, the code. I'm going to kind of break this up into 2 parts. I'm going to show you the code, go over this code, and then the next part we're going to run it in Colab. So first, let me show you this is actually 10 lines of code. 1, 2, 3, 4. Got our function signature here. 5, 6, 7, 8, 9, 10. All right. So the code here, the first 3 lines up at the top, this is where we are importing libraries, which I'll go over here in a second. Pandas, you should be familiar with that if you're interested in data science. This is, Pandas, Python, data frame, data processing for doing data science and machine learning. This Google Colab, we just went over that in step 4, where we're going to establish some keys, secrets, passwords, whatever. That was that library. And then this third library here, OpenAI, this is an open source library from OpenAI to send LLM prompts or requests over the internet to an LLM and get the response. Let me jump down here. The 4th line of code here is our role prompt. I'll go over that in the next section where we start running this code. Let's see, 1, 2, 3, 4, 5. This is our user prompt. This is where our agent in the end, when we start running it in Colab, you give it a question, analyze some data for me, and then the agent's going to do that data science for us. This messages variable is going to go into our OpenAI client. So this OpenAI client, like I was saying, open source library from OpenAI, we give it the endpoint or the base URL where we want to send, where our LLM is hosted, an API key that we went and got from build.nvidia.com in steps 3 and then integrated it in steps 4. All right, once we've instantiated this class into this object, this client object, we then go ahead and send that request with these 4 parameters. The model, there's more parameters than this. This is just kind of the minimum amount. So the model equals our llama nematron. The message is our role prompt and query or user prompt. Max tokens, how large the response we want to be. And then stream equals false. If you set this to true, you can see the thinking of the LLM or maybe the lines of code as they're created. But to simplify this, we set stream equal to false so we can get the LLM response all at once. This line of code is actually really simple. We're just grabbing the content portion of the response, the top choice, putting it in this LLM response variable. And then down here, all of this up here is mostly just LLM interaction. These 1, 2, 3, 4 or 5 lines of code are just LLM interaction. But down here, this Python exec function, we're going to take the response from the LLM and split off this markdown code, prefix, and then the 3 ticks for the suffix. We're going to peel those off of the response and be left with just the text of the Python code. And we're going to send that code along with our data frame that we're working with into this exec function, and it's just going to run it right away. So this is where we start leaning into more of agentic AI behavior, because we're giving it a question and it's going to just it's going to get code and run it all on its own. Instead of us getting the code and then typing the code or pasting the code and running the code, this is just going to give us the answer by running the code. All right. So that is the first part. Now I'm going to go ahead and copy this code into Google Colab. All right. Now we need to put this code into Google Colab. I will do the imports in their own cell. And remember, you always have to run. I'll run it again just in case, even though it kind of barks at me. If you do it more than once, it's fine. It doesn't hurt anything. You have to do that before you import pandas in order to GPU accelerate that pandas on the GPU. I will go ahead and put this role prompt. We'll come back to this. This is important. Prompting is important, obviously. And notice I have not filled this out yet. I'll do that in a second. I have one prepared, but let me go back to the code here. All right, and here is our agent codified as a single function, just as a toy example, a beginner example. Importantly, you have to have a data set. I have this set as a default parameter. Again, I kind of did that to squeeze it down into 10 lines of code. 10 sounds better than 11. But notice I have that data set in here, NC parking violations 2022. And that comes from my coworker, Jiwoo Liu, made this in Kaggle, which is what inspired this whole video. He has a much more robust example of this, if you want to check it out, in Kaggle. Much more robust example, much longer lines of code, or not much longer, but a few longer lines of code, more object-oriented. And so I took to understand his code, I simplified it, is the thing I do. And that is the code, that is the data set I'm using from his example. All right. So we have our code in here, except for the prompt. This needs to be a little more robust. I'm going to do single ticks. Whoops. And I have a fully written prompt here where I was testing out this code before. I'm going to paste that in here and then go over it. So again, the role portion of the prompt is where you're telling the LLM how to behave. Let me fix this right here. This is tabbed over. I don't want that. Okay, so my prompt, I told it you're an expert machine learning engineer, specializing in advanced quantitative analysis and engaging colorful plots using the Seaborn color palettes. And after playing with this a little bit, I found that I needed to kind of, instead of putting it into the user prompt, I wanted to put it in the system prompt so I wouldn't have to keep prompting the same pieces of information. For example, I gave it a sample code snippet of what I was going to do with its response. So I told it I'm going to give it a data frame and I'm going to give it a question, and I want the LLM to give me a Python snippet that is going to be run directly in the Python exec function. Here's where I gave it a little more detail, where I want to keep it concise. I want colorful plots. This is hit or miss. This is about 50%. I mean, they're always colorful, but not as colorful as it could be. I told it, just give it to me. Just give me the code. Minimize comments, right, and give it to me in the markdown format with 3 ticks with the Python tick, 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 and then at the very end that we peel off. I went over that. That's the last line of code. I even gave it a single shot example of a data frame and a user question and then the expected output. And there's that markdown header and then the ending 3 ticks that you use in Markdown to display code. And then finally, again, I got this from Jiwoo. Final instruction, just one solution, just the code, okay? I can't remember if I ran this yet. I'll run it again, Shift Enter to run it. Okay. So I pretty much have everything here. Let me just show the code here so you can, the data set so you can see what it looks like. Copy and paste that. And the code is what the description says. It is a bunch of parking violations and not terribly large. This is just 100 rows and 43 columns. Again, this is just for a getting started example. And we're going to go ahead and run a sample query. All right. So we'll say agent. Let me go ahead and put 3 ticks here. All right. How does the age of the car correlate to the number of parking tickets? All right. Moment of truth. And I did this, and it does need a little bit of modification. All right. So notice we have this car age over here because we have an error in the data. So I'm going to go ahead and edit my prompt here. Remove outliers where the car age is over, I don't know, 100. Whoops, that would work too. 100 years old. Now, what I should do is put that up in the system prompt. All right, here we go. Now, this is looking better. We've got the number of tickets and the age of the cars, but again, I want a bar plot. Show me the results in a, oops, it had it there, in a bar chart. Okay. And there we have it. Looks pretty good. I'm going to run it again just to see what happens. It should be a little different this time. All right, there we go. That's what I'm looking for. That's nice and colorful, right? We've got more than one color. We've got it gradiating over the age of the car. Light green for the younger car or new cars, and then dark blue as the age of the cars get older, and not too much of a correlation. And there's a warning there. It used palette, so it's using an older API of some sort. Let's see, remove warnings using the warning filter. That's another thing I would put up in the system prompt. Remove warnings using the warning filter. All right, there we go. Now this looks really good. This is our agent doing data science, data analytics for us. We gave it a question. It gave us the answer. Yeah, I think that's pretty cool, especially for 10 lines of code. So we have our steps to create the agent. We have the code, but I like to think of it theoretically as 3 ingredients. The first ingredient is the code generation. The second ingredient being the code or the data processing itself for the data science. And the third ingredient is execution speed. So ingredient number 1, we have the code generation. In our case, we're using an LLM hosted on build.nvidia.com. And the second ingredient is that code the LLM generates. In our case, we're using pandas, but again, you can use pandas, polars, Spark, any sort of Python data library for data science, data processing. And then that third really important ingredient is the speed. Of course, we're using NVIDIA GPUs. Everyone knows that NVIDIA GPUs help the training of the LLMs go, exceptionally fast. And we all know that for inference, NVIDIA GPUs are the best. But when we're doing data science and we're executing data science machine learning code, this is another thing that NVIDIA excels at. So we have this CUDA for data frames, or CUDF. This is going to take that code from the LLM and it's going to just accelerate it without having to change any code. And I think that's where this really comes together, because you have to do, like if we're doing hyperparameter optimization, you have to do lots and lots and lots of trials. So the more trials you can do in a certain amount of time, the more likely you are to build, a high accuracy model for your machine learning engineering. Or if we're doing data science and we're doing this with AI, we have to do lots of prompts, a lot of back and forth conversations, or if you have a multi-agent system, those agents talking to each other have to run that data science machine learning code as quickly as possible to get the answer back to you. So I think these three ingredients are all kind of the basis for creating a data science agent. So there's our data science agent built with three main ingredients: an LLM generating pandas code accelerated with NVIDIA cuDF. I hope you try it out. I hope you share something with us in the comments below, maybe a link to your project. And until next time, cheers and happy coding.